I'm covering 2-4 part 1, which is writing linear functions. So today we're going to use slope-intercept to write linear functions, calculate the slope using 2 points, and write equations using 2 points in slope-intercept form. All right, so as we looked at yesterday, linear equation slope-intercept form is y equals mx plus b, or f of x equals mx plus b, where m is our slope and b is our y-intercept. So here's our first example. Write the equation of the graph line in slope-intercept form. So that means I want it to look like that. And we have a graph, so we need two things. We need the y-intercept and we need the slope. So y-intercept is just where it crosses the y-axis. Here it's a pretty nice value, it's 1. So our y-intercept is equal to 1, that's going to be our b. Our slope, we're just going to pick 2 points on the line and look at our rise over our run. So remember, as you go right, if you're going down, that's going to be a negative slope. If you're going up, it's going to be a positive slope. So they have a couple points here. If I go from my y-intercept down to this point, you want to pick a point on a corner of the box so that you get whole numbers if you can. Sometimes your graph just doesn't cooperate, but if you can get a point on a corner of the box so that you can get a whole number, it's going to be easier. So if I start here, I'm going down 1, 2, 3. So that means it's going to be a negative 3 because I went down, and then right 1, 2, 3, 4. So my run is going to be 4. So now I have my slope and my y-intercept, and I just plug them in. Y equals negative 3/4 x plus 1. Okay, so one for you to try. For this graph, and these are a little hard to read, this is 2, 4, 6, 2, 4, 0, negative 2. So go ahead and try that one. All right, slope, calculating slope. So remember, slope, this is really all you need to gather from this slide. We know that slope is rise over run, so it's vertical change over horizontal change. If you have 2 points, it's going to be, so x1, y1, x2, y2. It's going to be y2 minus y1 over x2 minus x1. Find the slope of the line through those 2 points. It's always a nice idea to label your points. Then when you plug them in, you plug them in properly, because sometimes I'll see a y2 minus an x1 or an x2 minus a y1. People got the points mixed up. So, and then you just plug them into the formula. So it's going to be a negative 5 minus 1 divided by 2 minus a negative 1. Remember, a negative of a negative makes this a positive, so you end up with negative 6 over positive 3, which is going to be negative 6 over 3, or negative 2. Okay, find the slope of this line. So remember, if it's a linear equation, it's going to be constant change in x and a constant change in y. So you can pick any 2 points as your x1, y1, x2, y2. You'll get the same slope. So they've chosen this one and this one, the first 2 points. So this is going to be my x1, y1, x2, y2. Plug them in. You get 5 minus 2 over 8 minus 4, or 3/4. All right, find the slope of the line shown. So again, this is a horizontal line. So you can either remember that horizontal lines always have a slope of 0, or you can pick 2 points. They picked 0, they picked this point and this point, plugged them in, and they get 0 over 1, which is 0. So I get a lot of confusion about which one is 0 and which one is undefined. 0 on top, 0 in the numerator is 0, 0 on the bottom or in the denominator is undefined. Okay, you find the slope of a line with these points. Next example, you find the slope of a line with these points. So hopefully you're good at finding slope. We'll be using that most of the rest of the year. All right, the slope-intercept form, write the equation of the line that contains the points in the table. So this time we don't have a graph, we've just been given a bunch of points. So first thing we're going to do is find our slope. We know how to do that. Pick any 2 points and use the slope formula, y2 minus y1 over x2 minus x1. So they've picked this and this. And I said, and again, it doesn't matter which. I think they wanted to stay away from the points with the decimals in them, which is a good idea. So plug those into your slope formula, y2 minus y1 over x2 minus x1. You're going to get 6 over 16, or 3/8. You should reduce your fractions. So what do we know so far? So we know it's y equals mx plus b. We need to find this and this. I'm sorry, this and this. We just found our slope, so we plug that into the equation, and this is what it looks like so far. So we need to find our y-intercept. How do we do that? Well, we don't have it in the table here, but we have a lot of x and y pairs in here. So if we take one of these points, any one of these 4 points, plug the x-coordinate in here and the y-coordinate in here, now we have an equation with one variable, which is going to be b, and we can solve for b. So it says pick any point and plug x and y coordinate into the equation. And what did they picked this one. So you plugged the x right in here where the x was. You plugged the y here where y is supposed to be, and then we solve. So 3/8 times 8 is going to be 3, and then we subtract 3 from both sides. We find our y-intercept is -2. And now we can plug that in for the final version of our equation, which is 3/8 x minus 2. Okay, I have a problem just like that. It just looks differently. And it seems to cause confusion because we're just starting to get used to function notation. This is actually similar to the last problem, except the points that have been picked out for you. And you may not be obvious to you right now. So you want to write the equation of the function f of x, where f of 4 is equal to 1 and f of 1 is equal to 4. So remember what this means. If I had the equation x plus 2, f of x equals x plus 2, and I asked you to find f of 4, that means take x and substitute 4 in, and then evaluate what the answer is. So if I plug 4 into this equation, it's going to be 6. So what does that mean? It means that in this equation, for an x-coordinate of 4, I have a y-coordinate of 6. So this is really a fancy way of writing an ordered pair. So you want to rewrite these as ordered pairs. The value in parentheses is our x. That's the value of the independent variable that we're going to plug into the equation to get the output value. So remember, x is input, y is output, and this is going to be our output value. So this is our y. So x, y, x. I know it's terrible looking x, y. So rewrite them as ordered pairs. So f of 4 equals 1 is the ordered pair 4, 1. F of 1 equals 4 is the ordered pair 1, 4. And now we use the same procedure that we just did. We're going to find our slope. So x1, y1, x2, y2. So 4 minus 1 over 1 minus 4 gives us a -3 over 3, or a -1. And now we're going to, so we've got y equals -1x plus b, and we're either going to pick this point or this point to plug in our x and y and solve for b. So I picked this point. So I'm going to plug my x coordinate in here where x is supposed to be, my y coordinate in here where y is supposed to be. And now I'm going to solve. So this gives me 4 equals a negative 1 times 1 plus b. This is 4 equal negative 1 times 1 is just negative 1. And now if I add 1 to both sides, I get 5 is equal to b, which is our y-intercept. And that gives me a final equation, y equals a negative x plus 5. So don't get tripped up on this notation. It's just another way of giving you 2 points that are part of the line. All right, so you should practice this one. These are the problems that tend to, this is the type of problem that tends to cause the most confusion. Please bring any questions to class. Here's your homework, and there is a new web activity.